So let us consider this function as fx. So this limit becomes limit x tends to infinity f of x, and this function has gx. Okay, so this becomes this. Okay. Limit x tends to 0 f of x whole to the power gx. Now for this kind of formation of limit, we can use the L'Hopital method. Okay. So there are many different methods, but using the L'Hopital method, I think this will be the most simple one. What I meant to say is, if you see any limit which is in form of this, okay, so I think L'Hopital rule is one of the easiest method you can go for, okay, for this kind of limits. So we're doing it with the L'Hopital method. Okay, so at first what we're going to do is we're going to take the whole thing as y. So let y equal to this. Okay, now taking log in both sides, so this becomes log of y x log of 1 plus 1 by x square. Okay, now as you can see on the right side there is no actual denominator. Okay, so like there is actually denominator which is 1, but we cannot I mean if we differentiate this we'll get 0 obviously. So like there is no actually like proper denominator here. Okay, so we need a denominator to use the L'Hopital method. So what we're gonna do is we're gonna take x as 1 by z, or we're gonna take z as 1 by x. So let z is equal to 1 by x. Okay, so what do we get? Log of y, this will be log of 1 plus z square by z. Now you see there is a denominator, like if we differentiate this we won't get 0. Okay. So now take limit on both sides. Limit x tends to infinity log of y, and okay, so we actually can't take limit x tends to 0 here, as both of the numerator and denominator are of function z fz. Okay, so as x tends to infinity, see as x tends to infinity, so it will be 1 by infinity, then z will be 0, so z tends to 0. Right here limit z tends to 0 log of 1 by z square by z. Okay. So let me clear this one. So now what do we get? We get limit x tends to infinity log of y is equal to, okay, so now we're putting z equal to 0. This will be log of 1, which will be 0, and z equal to 0, so z is going to be also going to be 0, so this will be 0 by 0 form. Okay. Then now we are going to use the L'Hopital rule here. So what we're going to do in this rule, we're going to differentiate. So now as it is 0 by 0 form, as it is in 0 by 0 form, we're gonna use the L'Hopital method. Okay. So in this method, what we do is we differentiate both the numerator and the denominator. Okay. So limit z tends to 0 become so now we're going to differentiate both the numerator and the denominator. And what do we get? Limit z tends to 0, differentiating the log of 1 by z square, we get, what do we get? 1 by 1 plus z square, and z square is 2z. Okay, and this will be 1. Okay. Now we are putting z equal to 0, so this becomes 1 plus 0, it becomes 1, and it becomes 0, z, and the whole thing becomes 0. Okay, so what do we get? Limit x tends to infinity log of y equal to 0. Okay, so we get these. Let me clear the whole thing. Now limit x tends to infinity log of y equal to 0, which is log of 1. From here what we can write is log of limit x tends to infinity y is equal to log of 1. From here what do we get? So log of this equal to log of 1, so this becomes 1. Limit x tends to y equal to 1, and y is our this function, so limit x tends to infinity 1 plus 1 by x square whole to the power x becomes 1.